This video is going to talk about equivalent expressions. Remember that to evaluate an algebraic expression, you have to replace the variables with numbers. So, we are jumping all over the place just to start off. So, if we have this table here, and we're going to complete this table. Let's say that we have two expressions. We have 2n and n plus n. So if I replace n with 1, 2 times 1 is 2. 1 plus 1 is 2. If n is 2, 2 times 2 is 4. 2 plus 2 is 4. If n is 3, 2 times 3 is 6. 3 plus 3 is 6. If n is 4, 2 times 4 is 8. 4 plus 4 is 8. Do you see how both times we end up getting to the same number, even though the expressions look different? That's because they are equivalent, which means they mean the same. They equal out to be the same thing. 2n is the same thing as saying n plus n, because multiplication. So let's go ahead and complete these tables to show that these expressions have the same values each time. You can go ahead and work this out on your own, or you can work it out with me. So if n is 1, that means that this expression is going to be 2 times 1 minus 2. What I'm actually going to do for simplicity's sake is I'm going to go straight down the row and fill these out, and then I can go back and figure them out later. 2 times 2 minus 2. 2 times 3 minus 2. 2 times 4 minus 2. It's always an adventure to write with this pen. So, remember that PEMDAS says that we're going to multiply first. 2 times 1 is 2. 2 minus 2 is 0. 2 times 2 is 4. Minus 2 is 2. 2 times 3 is 6. Minus 2 is 4. 2 times 4 is 8. Minus 2 is 6. Then we're going to go ahead and go over to the other side, which is going to be multiplying 2 times, but now that n minus 1 is in parentheses. 1 minus 1. And then we have 2 times 2 minus 1. 2 times 3 minus 1. And 2 times 4 minus 1. So when we do what's in the parentheses first, 1 minus 1 is 1. 1 times 2 is 2. 2 minus 1 is, 1 minus 1 is 0. 0 times 2 is 0. Got a step ahead of myself there. 2 minus 1 is 1. 1 times 2 is 2. 3 minus 1 is 2. 2 times 2 is 4. 4 minus 1 is 3. 3 times 2 is 6. And you can see that each time we're getting the same final answer. So these two expressions are equivalent. Let's take a look at letter B. 2n plus 2 or 3n. Well, remember that each time we're going to be multiplying 2 times whatever n is, and then we're going to be adding 2 each time. So when n is 1, 2, 3, 4, it's going to adjust the chart. 2 times 1 is 2, plus 2 is 4. 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6, plus 2 is 8. 2 times 4 is 8, plus 2 is 10. Then we go over to 3 times n. So we're going to be multiplying 3 each time. 3 times 1, 3 times 2, 3 times 3, 3 times 4. And when we do this, 3 times 1 is, did I do that right? Yes, 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So this is these two are not equivalent because we're getting a different number each time. So let's take a look at the area of this rectangle that's right here. We can see that the area of the rectangle would be 4 because 1 times 4 is 4 units squared. What if we found the area of 2 rectangles? Well, we could multiply 1 times 4, get 4, and then multiply that times 2, or we could multiply 2 times 4. Either way, we'd get 8 units squared. So before, they were looking at this way. To show what this would look like, we're going to take a look right here where we join this up. And now 1 and 1 make 2. They want us to write an addition equation and a multiplication equation to find the area of each figure. So we're going to write this 2 different ways. Over here, we have 4 different rectangles that are 6 by 1. So to find the area of one rectangle, we'd multiply 6 times 1. Then we'd have to multiply all of that times 4 because there are 4 of them. When we come over here, we see that this rectangle is all 4 of these all joined up into one rectangle. So to find the area of this one, we would multiply just 6 times 4. Both of these will end up getting to be the same answer. Now, you might have noticed they were looking for an addition equation and a multiplication equation for the area of each figure. We wrote out the multiplication equations. What you could do is for letter A, for the first one, you would see 6, 6, 6, and 6, each one of those areas. So we could call that 6 plus 6 plus 6 plus 6. Then, over here, to find an addition equation for this, it would look the same because each of these are 6 across. So you could write this addition equation, 6 plus 6 plus 6 plus 6. It depends on how you choose to interpret the problem. Looking at letter B, we see that this area is 4 and this area is 4. So we could add 4 plus 4 to get 8, or we could multiply 4 times 2 to get 8 for both of our areas. Remember, these would be in units squared. Sometimes the dimensions of a rectangle are not given. This rectangle is a strip of n squares whose length and width are equal to 1. The length of the rectangle is n, so the area of the rectangle would be 1 times n. 1 times any number is just that number. So the area of the shape, 1 times n, is the same thing as saying n. You would also say n units squared, but putting the label on this would end up confusing the variable and the label. So the rectangle, the area of the rectangle is n. So the area of 2 rectangles would be n plus another n. Or you could say 2 times n. The 2 figures have an equal area. It's just we don't know what that one dimension is. These are equivalent expressions. N plus n is the same thing as saying 2n. So now they want us to write more equivalent expressions. In letter A, we see that these are all n's here. So this would be n plus n plus n plus n is equal to saying 4 n's, or 4 groups of n. In letter B, we see that there are n's and 2's. So what we would see here is we could add n plus 2 plus 2 plus n. That's one way that we could write that out. Or we could go ahead and combine this to be 4 plus 2n's. We know that the 2 plus 2, we know that when we combine those up, that's going to be 4 squares right there. We also know that right here, we don't know how many of these there are, but we do know that there are 2 of them. So this is saying 4 plus another 2 groups of however many n is. The commutative property states that the order in which we add or multiply numbers doesn't matter, as long as we are just adding or just multiplying. So, examples of this would be n plus 2 is the same thing as saying 2 plus n. N plus 3 is the same thing as saying 3 plus n. 5 plus x is the same thing as saying x plus 5. 4 times n is the same thing as saying n times 4. And 2x is the same thing as saying x times 2. Now that last one looks a little bit different, but don't let it scare you. Remember that no sign means multiplication. So you could also write that as 2 times x. But look at all those x's in there. It's starting to get confusing. Maybe you're going to write it as 2 dot x, which is the same thing as multiplication. Or you can just write it as 2x. The distributive property of multiplication over addition and subtraction says you can do the following, which they've shown one way. I'm going to show using a lot of arrows and underlining. When you multiply 2 times 4 plus 11, you can multiply that 2 times everything in the parentheses first. So 2 times 4 and 2 times 11. So you can see that this means the same as 2 times 4 plus 2 times 11. You see 3 times 6 minus 13 is the same thing as saying 3 times 6 minus 3 times 13. See the plus sign here, the plus sign here, subtraction here, subtraction here. Very important to keep in mind. Over here, they flip-flopped the order. They put the 6 on the other side. Not a big deal. 6 times 5, 6 times 2. 6 times 5, 6 times 2. And that subtraction sign in between. The distributive property holds for all numbers. So instead of the numbers, you can also use variables which represent numbers. For example, in the problem, let's just go down here. In the problem, 2 times n plus 4. When I multiply 2 times n, that's just going to be written as 2n. Then I multiply 2 times 4. I know what 2 times 4 is. 2 times 4 is 8. So I'm going to write 8, and then I'm going to take that sign and put it in the middle. Same thing over here in this example. 2 times 3 plus 4, 2 times 3, 2 times 4. When we add those two up together, 2 times 3 is 6, 2 times 4 is 8, then we add them together and we end up with 14. So they want us to use the distributive property to write an equivalent expression. So all I'm going to do is I'm going to draw those arches. 3 times x is 3x. 3 times 4 is 12. There was an addition sign, so I'm going to put an addition sign. 2 times 3 is 6. 2 times x is 2x. So I'm going to go ahead and I'm going to put that addition sign. Do you need to circle it every time? Absolutely not. But I don't want you to forget that it's there. So in the beginning, if it's a habit that you use, fantastic. But know that it's not necessary. 4 times x, 4x. 4 times 3 is 12. We've got that subtraction sign in there. So we're going to put that subtraction sign down there. And for our final one, now we're going to multiply x into everything. X times 4 is 4x. X times 2 is 2x. We have a subtraction sign in there, so that's what we're going to put. Now they want us to fill in the blanks. They want us to undo the distributive property. This says 3n plus 6. If we divide 3 out of these, instead of having 3n, I'm going to take 3 out. That means I'm just going to have 3 here. 6 divided by 3 is 2. I've divided it out. 3n divided by 3 means I'm going to have 3 times n divided by 3, which means those two cancel out and I just have n. 5x plus 25 means I'm going to divide 5 out. 5 times x divided by 5 means I'm actually not doing anything to x, it's just x. And then I'm going to divide 5 from 25, and that leaves me with just 5. 4y plus 12, what do I get rid of there? Well, I'm going to go ahead and take the 4 out, because I can divide 4y by 4, and I can divide 12 by 4. So I'm going to end up taking 4 out. I'm just going to have y left, and there will be 3 left on the other number. Go ahead and try to work these out on your own, and then we'll talk. So I've divided out 3. Now if I take 3 out of each of these, I'm not multiplying 3 and I'm taking 3 out. 6n divided by 3, well, let's go ahead and do this first. 6 divided by 3 is 2. So 6n divided by 3 is going to be 2n. Now it's getting a little bit more tricky. 4x plus 10, take the 2 out, divide 2 away, leaves me with 2x plus 5. 10n plus 35, to take 5 away, would be 2n plus 7. And if you're not sure why this is happening, redo the distributive property. 5 times 2n is 10n. 5 times 7 is 35. You can see I get back to the original expression. Remember that the numbers 3 and 6 are factors of 18 because they multiply to give 18. When you rewrite an expression such as 6x plus 15, this process is called factoring the expression. Even though 2x plus 5 is the sum of the two terms, it's also a factor of a larger expression, 3 times 2x plus 5. So in this case, the two factors are 3 and 2x plus 5 because those are the two numbers being multiplied together. Even though 2x plus 5 is more than one number included, because it's in that parentheses, we're treating it as one number. There's an unknown in there, and the parentheses help us know that those are all together. The factors of this expression would be 5 and 3x plus 7. Finding the GCF can be helpful, finding the biggest number that goes into both of the numbers. So the GCF, the biggest number that multiplies into 12 and 18, would be 6, so that would be the biggest number that you'd be able to pull out. So what can we pull out of 6x plus 9? Well, we could pull 3 out. That would leave us with 2x plus 3. 12y plus 30, well, what's the biggest number that can go into both 12 and 30? That would be 6, so that would leave us with 2y plus 5. 15n minus 25, the biggest number we could pull out of that would be 5. That would leave us with 3n minus 5. And then our final number, 21x minus 49, the biggest number that goes into both of those is 7. That would leave us with 3x minus 7. Take a look at the associative property, reminding you that you can change the parentheses around. You can change the order that you multiply or add numbers, so long as you're just multiplying or just adding. We could use the associative property to simplify some of these expressions. So instead of multiplying 2 times 5x, we could multiply 2 times 5 first and then times x, because 2 times 5 is 10, and that 10 times x is just 10x. So multiplying 3 times 5 would get us 15 multiplied times y. When we get down to the more complex ones, we would see that we have all of these numbers. We're going to keep them on each side of the addition-subtraction sign because they're going to kind of start to get mixed up a little bit. 4 times 3n, 4 times 3, that would be 12n, minus 3 times 2n would be 6n. Now if I have 12 n's and I take 6 n's away, how many n's are left? 6 n's. Over here, 3x times 2, 3 times 2 is 6, that'd be 6x. And then we have 3 times 2x, 3 times 2 is 6, that would be 6x. So now I have 6x plus 6x. So if I have 6 x's and I add 6 more x's, I have 12 x's. That's a lot of x's. You can also do this kind of the way I was just doing it before, just by working it through. 2 times 3, because we can change the order that we're going to multiply things. 2 times 3 is 6. That would be 6p. Then we go into 3 times 7m times 2. Oh boy. Let's multiply 3 times 2 first. 3 times 2 is 6 times 7m. 6 times 7 is 42. That would be 42m. Then we get into letter C, where we have multiplication grouped up, and then another multiplication group up, separated by that addition sign. 3 times 2x is 6x. 4x times 5 is 20x. If we add 6x's plus 20x's, we get 26x's. For our final one, 8x times 3 is 24x, minus 4 times 6x, 6 times 4 is 24x. 24x minus 24x, nothing. Ladies and gentlemen, have an absolutely spectacular day.